So let's do the odds. So we have the absolute value of negative 12.6. Recall the absolute value, and when we're talking distance from 0, that's a positive number. So even if it's positive in here, it would still be 12.6. If it's negative, it's 12.6. It's 12.6 units away from 0. So regardless of what the sign is on the inside, the answer will always be positive. Now if the negative was on the outside, and even if there was a negative on the inside there as well, then we would say the opposite or the negative of the absolute value of negative 12.6. The absolute value of negative 12.6 is positive 12.6, but they want the negative of that. So the only times you get a absolute value that's negative is if there's a negative in front. Okay? So the answer to that is 12.6.
So a negative makes a positive, right?
Okay, so this is a two-step equation. 4n minus 5 equals 15. So we need to isolate the n or get the n by itself. So I'm going to add 5 to both sides. And that's going to give me 4n on the left, 20 on the right, and divide by 4. Yep. So final answer is n equals 5. And you can always check your answer by plugging it back in. 4 times 5 is 20, and 20 minus 5 does indeed equal 15. So this answer does check. Is a word problem, and we have the sum of 3 consecutive integers is 318. Find the integers. So the first thing we have to decide is, what does consecutive mean? Well, consecutive means like 3, 4, 5. This is an example of consecutive numbers. 3, 4, 5. They're in a row, right? So we don't know what our numbers are. This is just simply an example. So I'm going to let x be my first number. I'll just say first integer. Not x plus 2, because if we're taking this as an example, consecutive, how do you get from 3 to 4? That is taking the first number and adding 1 to it. And so that's going to get us the second integer. Now, if it said consecutive even integers or consecutive odd integers, then we're adding 2 every time. Because to get from, like, if it was 2, 4, 6, to get from 2 to 4, that's a plus 2. Okay. But here, we just want consecutive integers, so that's why I like to put an example in the corner, just so I know what I'm looking for. I'm looking for 3 numbers in a row. And to get from the first number to the next number, that's going to be an addition of 1. Now, remember, I have to find 3 numbers. So x plus 2 is going to get me the third integer. In other words, I add 1, and then I have to add 1 again to get to that third number. So this is kind of setting up algebraically what I'm going to do. Now they're telling me that the sum is 318. So I'm going to add, because sum means add, all 3 of my integers. So I have x as my first integer, plus, here I'll change the color so you can see, x plus 1 would be the second integer, and then x plus 2 is my third integer. And those total 318. So I'm adding all 3 of those together. So what I really have is a multi-step equation. I can now combine all of my like terms because I have an x, and I have a plus x, and I have another plus x. So I have 3x. And then I have numbers, a plus 1 and a plus 2, which means a plus 3. Once I get to this point, now it's a 2-step, like the previous problem we just worked. So I would subtract 3 from both sides. 3x equals 315. And then divide by 3. I'm running out of space. So x equals whatever 315 divided by 3 is. Somebody got a calculator? 105? Okay. Now, it says find the integers. So I found one of them. So if the first one is 105, what's the next number?
106.
106, and what's the next number after that?
107.
107. So here are our answers. 105, x is 105, which means the x plus 1 would be 106, and x plus 2 would be 107. And you can always add those three numbers together, and they should total 318. We have negative 5z plus 5 is greater than negative 6z plus 12. Now remember, you treat inequalities the same way you treat equations. So we've got variables on both sides. We need to get them all together on the same side. I like for my variable to always be on the left, so I'm going to move my z term from the right to the left, which means I have to add it to both sides. That's going to leave me negative 5z plus 6z on the left ends up being 1z plus 5 greater than,
See,
I'm sorry?
you said,
7.
Negative 5z plus 6z is 1z, yes.
Yep.
And then so we have z plus 5 is greater than, and it would be 12.
see a 1 on there then.
Now, finish solving it, so I'm going to subtract 5 from both sides. And that's going to give you z greater than 12 minus 5 is 7. So z greater than 7. Make sure you put greater than 7. If you put equals 7, I'll take off a point. Because greater than 7, we have infinite solutions. Any number greater than 7. If you put equals 7, you're saying there's only one answer, when there's actually infinite answers. So there's a big difference between an equal sign and a greater than sign. So please make sure that you do put the sign that is in the problem, okay, needs to be in your answer. Now remember, there's one situation where you have to reverse your symbol. Do you remember what that is?
Yes.
If you multiply or divide by a negative number, then you have to reverse your symbol. So had we any time in there had to multiply or divide by a negative, then I would have switched from a greater than to a less than. But that's the only thing. Adding and subtracting, it does not matter. It's just when you multiply or divide. Which I don't think, because even looking at the next one, like 9 and 10, I don't think you're going to have that scenario in that problem either. So let's look at number 9. We have 7y plus 12 greater than 6y plus 20. So this ends up being almost identical to the last problem that we worked. Again, we got to get all of our variable terms on the left. So it's going to leave me y plus 12 greater than 20. And then I have to subtract 12. So y is greater than 8. So same process as the last problem. Just get all your variable terms on the left side and then get your y all by itself. Number 11 says find the slope. You'll have a formula sheet and the slope formula is on it. And the slope formula pretty much is you're subtracting your y's in the numerator and subtracting your x's, in the denominator. So remember, it's rise over run. Rise is your y's, so that's how you can remember what goes on top. So the y's are on top. So I am going to do 5 minus 5. And the one thing to remember with slope is make sure you go in order. Now for my numerator it doesn't matter because both my y values are 5. But if I do the 5 that's paired with the 8 first, if I go 5 minus 5, then I need to go 8 minus 1. And like I said, it's not going to matter on this problem, but if you have other numbers, that could make a difference. So 5 minus 5, and then I'm going to go 8 minus 1. And the reason why it doesn't matter is because it doesn't matter what's on the bottom at all. If I have a 0 in the numerator, that means my slope is 0. So it doesn't matter what's on the bottom. If I got a 0 in the numerator, my slope is 0. Now, what if I would have gotten a 0 in the denominator? It's undefined. So yeah, make sure that you remember that if you've got a 0 in the numerator, the answer is 0. If you have a 0 in the denominator, it's undefined. Now, let's take this one step further. Can you tell me what the line looks like with a slope of 0?
0.
A slope of 0 is a horizontal line. If we were to graph these 2 points, they would be side by side. So the line would be horizontal. If it was an undefined slope, we would have had a vertical line. If we would have plotted the 2 points, they would have been stacked. So it would have been a vertical line. So we have an equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. The m is your slope, so that's rise over run. And your b is your y-intercept. So because it's in the proper form, I know that my y-intercept is 1. So it crosses the y-axis at 1. So I can go ahead and plot my 1 on the y-axis. Then I use my slope. Okay, my slope is the number in front of the x, which is 1. Well, remember, we need a ratio. It's not just 1. Our slope is always a rise over run, and you can turn any number into a fraction by just putting it over 1. So what this tells me is I'm going to go up 1 and over 1. From the point I just graphed, though. I don't go back to 0, 0. From the point I just graphed, I go up 1 over 1. And that's going to give me a dot about right there. Now I can draw my line. And that's my graph. So I plotted my intercept, and then I used my slope to find another point on the line. I went up 1 over 1.